Hey guys, welcome to Volumes of Revolution. So this is a few more examples using the disk and washer method. So our first example is find the volume V obtained by revolving the region y equals x squared plus 4 and y equals 2 about the x-axis for x being between 1 and 3. So the first thing you want to do is sketch your figure. So I've put a general sketch up here. So first I'm going to sketch the figure. Remember that r is the outer radius, big R is the outer radius, and little r is the little radius. Okay, so here is my x plus 4 graph right here going up in general. I drew the blue line of y equals 2. Okay, we're going about the x-axis, so there's a little blue arrow I rotate around. So this point is going all the way around. Okay, and these points are going all the way around. So here's my graph. All these points are rotated down here. Okay, so I graph the figure, and it looks like I'm going to have a washer here. Okay, so I look at my problem, and then I see big R here. So big R is the radius from the x-axis to the top of my function. Little r is the radius from the x-axis to the line y equals 2. So I've defined my r and little r, and I've drawn my figure, so now I know what type of volume I have to find, or at least which method I'm going to use. I knew I had to find volume. Okay, whoops. So by definition, we have the volume is equaling, there's pi, equals r, big R squared x of x minus little r squared of x dx. So there's my general formula. So by substitution, big R was from the radius to the curve. So big R is going to be x squared plus 4. Little r is from the x-axis to the y equals 2 line. That distance is 2, so my little r is 2. Okay, now I simplify. So I have pi times the integral from 1 to 3. I've multiplied this out, and I got x to the 4th plus 8x squared plus 16x minus 2 squared, which is 4. So I'm left with this integral from 1 to 3 times pi right here. And I go ahead and integrate that. And I get pi times this function here. And so now I have to plug in 3, and then I have to subtract off when I plug 1 in. When I do that, I get 2,126 pi over 15. If you put that in decimal form, it's about 445.268. Okay? So that's our first example. Now, depending on if we're revolving around an axis and we have a separate line, can mean the difference between you using a washer and a disk. So in this example, I'm going to find the volume obtained by rotating the graphs of y equals 9 minus x squared and the graph of y equals 12 about the line y equals 12 for 0 is less than or equal to x and x is less than or equal to 3. So now I have two lines here, okay, or two curves. But I'm rotating about one of those curves. So this stays as a disk, not a washer. Okay. So here's the line y equals 12. Here's my function 9 minus x squared right here. And so I'm rotating about that line. So those points are rotating about that line. Okay, and I drew the arrow here to rotate about that line. So I only have one radius here. So from here to the top, okay, is my radius. So to get that, I have to take 12 minus f of x. Okay, so 12 minus, and the reason why it's 12 minus f of x, or in this case y, excuse me, is that my line was above my function. Okay, so that's the original. This is the other one. This is the revolution of the rotation here. Okay, so because that line, that y equals 12 line is above my curve, okay, it's going to be 12 minus y. That's big R. That's how we find the radius. Okay, so I go ahead and substitute 12 minus 9 minus x squared. I end up with 3 plus x squared. So now I'm ready to use my volume formula. So volume is equal to pi from 0 to 3, and that was defined for us. And then r, big R squared times x dx. So big R was 3 plus x squared. So there's the integral that I'm going to perform to get the volume. Okay, so here's the integral. I rewrote it for you. Pi times the integral from 0 to 3 of 3 plus x squared squared. And I go ahead and square that out, and this is what I get, 9 plus 6x squared plus x to the 4th. So I used some algebra there. Now I integrate the antiderivative, and I get pi times 9x plus 2x cubed plus x to the 5th over 5, and then I have to evaluate from 0 to 3. The good thing is, since each of these have x terms, I don't have to do the second one, so I just have to plug 3 into each of these, simplify, and multiply that pi. When you do that, you get 648 fifths times pi, or 407.150. I used f and int there to get that value to check. Our final graph, our example here, find the volume of the solid obtained by rotating the region under the graph of f of x equals 9 minus x squared for 0 to 3 for x about the vertical line x equals -2. So this took a little bit of time. So what I did is I drew my figure. There is the 9 minus x squared, a little different than the last example. I spaced it out. So here's my first graph. My dotted line is the vertical line x equals -2. So then these points have to revolve around that line. So there's equal space from here to here, here to here, right? So I drew my figure, and I know that big R is from this line to the figure, little r is from this line to the axes, okay? So we're going from 0 to 3, so little r is going to be 2, that distance from x equals -2 to 0. Okay, big R is going to be the square root, so big R is going to be r squared minus little r squared is going to be the square root of 9 minus y plus 2 squared minus 2 squared, okay? So when we do this, I did the algebra first instead of plugging in the function, so I went ahead and tried to simplify this first, okay? And so I go ahead and do that. I had to square this out. 2 squared is 4, so there's the -4. These cancel, and so I'm left with this, okay? And we want to take the integral. Forgot pi there. We're going to have our pi. Okay, so we're going to integrate from 0 to 9. So we're not looking this way from 0 to 3. We're going from 0 to 9 on the limits of integration. So I think I rewrote that integral. I did. So here's the integral, and then I go ahead and take that integral. So pi times 9y minus 1/2 y squared minus 8/3 times the quantity 9 minus y to the 3/2 from 0 to 9. When I do that, I end up getting 225 over 2. So those are 3 more examples on the volumes of revolution. You saw a couple washer methods on 1 and 3, and example 2 was a disk method. If you guys have any questions or comments, you can type them below, and we'll see you next time.